For an engine to run efficiently and correctly, it must receive the correct amount of clean fuel at the correct time. In this video, we'll have a close look at port-injected fuel systems. Older EFI vehicles use a fuel return type system, with filtered fuel delivered to the rail and injectors and then returned to the fuel tank after passing through a fuel pressure regulator. This type of system has a tendency to return heated fuel to the storage tank. The introduction of warm fuel causes the fuel to evaporate at a higher rate. This then causes an increase in evaporative emissions. Newer systems are returnless types. The pressure regulator is built into or very close to the fuel tank. Fuel pressure and flow is controlled at the start of the journey. Without a return line, fuel tank temperatures remain low, therefore reducing evaporative emissions. Although electric fuel pump control circuits may vary, their operation remains the same. One of the most common types is the in-tank roller cell or impeller pump. This pump is driven by a small DC electric motor. The impeller is attached to the end of the armature shaft. When the armature and impeller rotate, fuel is drawn through an in-tank strainer to the intake port. Fuel is forced around the impeller housing and across the armature windings. The movement of fuel across the windings lubricates and cools the DC motor. The fuel is then forced past a check valve and exits at the discharge port. The check valve exists to maintain fuel line pressure when the ignition is switched off. By retaining this line pressure, fuel boiling can be minimised. In the case of fuel line restriction or blockage, a pressure relief valve is built into the pump. This opens if the system pressure rises above a manufacturer's preset limit. When the relief valve opens, fuel is discharged back to the tank, preventing the DC motor from overheating and being damaged. The fuel pump is normally mounted inside the tank in a housing called a modular reservoir assembly, or MRA. The MRA acts as a swirl pot. This keeps the pump cool and reduces fuel starvation. The MRA may also house the fuel level sender unit. The fuel pump delivers fuel through a metal or plastic pipes to the filter and then the rail assembly. The fuel rail acts as a fuel reservoir and mount for the fuel injectors or pressure regulator. The rail may have a port for pressure testing. The fuel injectors are electromechanical devices that meter and atomise fuel so it can be delivered to the intake manifold. O-rings are used to seal the injector at the manifold and fuel rail. A plastic insulator may be used to provide some thermal insulation from engine heat. Petrol injectors consist of a solenoid, a needle valve and nozzle. Ignition voltage is supplied to one side of the injector from an ignition relay. The ECM operates the injector by controlling the ground path to the injector via a low side driver. When the solenoid is energised, a magnetic field is created within the windings and the armature is pulled into the injector body. Because the needle valve is attached to the armature movement lifts the needle from its seat. The sudden drop in pressure allows fuel to pass through the inlet filter, through the injector body, around the needle and valve, exiting the injector at the pintle as a finely atomised spray. When the ECM deactivates the low side driver, the solenoid magnetic field collapses. The armature and needle valve are closed by spring-assisted fuel pressure. The atomised spray is shut off and the next injector in sequence is activated as before. Fuel flow through the injector cools and lubricates the moving armature. The amount of fuel released by the injector depends on battery voltage, the available fuel pressure, and the time the needle is held off its seat. Port fuel injection return type systems have a pressure regulator located on or near the fuel rail. The regulator is constructed with the diaphragm and valve assembly in the centre. A spring seats the valve on the fuel outlet. A vacuum hose is connected from the intake manifold to the vacuum inlet on the regulator. This hose supplies vacuum to the diaphragm. When the engine is running at idle speed, high manifold vacuum is applied to one side of the diaphragm in the pressure regulator. Combined with fuel pressure, the closing force of the diaphragm spring is overcome and the valve is lifted from its seat. This allows fuel to flow from the regulator via the return lines back to the storage tank. As the throttle valve is opened, intake manifold pressure rises. This change in pressure results in the regulator spring closing the diaphragm valve. The opening and closing of the fuel pressure regulator maintains a constant pressure differential across the injector. Nearly all late model injection systems use a returnless system. The fuel pressure regulator is located internal as part of the MRA or very close to the fuel tank. The returnless type regulator operates in a very similar way to the return type, but without the need for intake manifold vacuum. It works as a maximum pressure limiting valve. Fuel pressure from the pump acts directly on one side of the diaphragm, with opposing force supplied via a diaphragm spring on the other. When the fuel pressure is great enough, spring pressure is overcome and the relief valve is lifted from its seat. The fuel is returned directly to the fuel tank. Some returnless systems can further control fuel pressure by varying the speed of the fuel pump. A slower pump speed results in less fuel flow and therefore lower pressure. The fuel pump speed is achieved via a PWM output from a fuel pump control module. If the fuel pressure remained at its maximum value at idle, the fuel injectors would not be able to operate fast enough to maintain correct air-fuel ratios. By lowering the fuel pressure at the injector, less fuel is passed through the injector nozzles. This allows for a longer injector pulse width and more precise control over air-fuel ratios. Feedback is achieved with the use of a low-pressure sensor. Always remember that a fuel pump creates flow and not pressure. The pressure is created due to the restriction of flow. Thanks for watching. See you next time.